the solutions from exercise 7.1 from chapter Coordinate Geometry. So in this exercise, we're going to be looking at questions that are based off of the distance formula. So the distance formula states that the distance between 2 points P and Q is given by whole root of x2 minus x1 the whole squared plus y2 minus y1 the whole squared. So in the first question, they're asking us to find the distance from the coordinate 2, 3 and 4, 1. So we're going to assume that this be x1, 3 be y1, 4 be x2, and 1 be y2. We're going to substitute the values of x1, y1, and x2, y2 in this formula in order to find the distance between these two coordinates, which we're going to assume as A and B. So the distance between the points A and B will be given by whole root of x2, which is 4, minus x1, which is 2, whole squared, plus y2, which is 1, minus y1, which is 3, the whole squared. So when we simplify this, we'll get 4 minus 2 is 2, so 2 squared, plus negative 2 squared. 2 squared is equal to 4, and negative 2 squared is also equal to positive 4. So 4 plus 4 will give us 8, and 8 can be further simplified. Root 8 can be further simplified and written as 2 root 2. So 2 root 2 units is the distance between the points A and B. In the second question, the two coordinates are negative 5 and 7 and negative 1 and 3. We're going to assume this as x1, y1, x2, and y2. Substituting this in the distance formula, let's also assume that the name of these coordinates be A and B. So the distance between A and B will be given by this formula. So negative 1 minus of negative 5 squared plus 3 minus 7 squared. So AB is equal to negative 5, minus into minus become plus, so positive 5 minus 1 will give us 4 squared. 3 minus 7 will give us negative 4 squared. So AB is equal to the whole root of 16, and negative 4 squared is 16, so 16 plus 16. We know that 16 plus 16 is 32, so in order to simplify root 32, we can rewrite this by finding the prime factors. So root 32 can be written as 4 root 2, so the distance AB is equal to 4 root 2 units. In the third question, the 2 points given are A, B, and negative A, negative B. So we're going to take this as x1, y1, x2, and y2. Substituting this in the distance formula, we're going to get negative A minus A whole squared plus negative B minus B the whole squared, which is equal to the distance AB. So negative A minus negative A will give us negative 2A squared plus negative B minus negative B will give us negative 2B squared, which is equal to the distance AB. So negative 2A squared will be 4A squared, and negative 2b squared will be 4b squared. Now we're going to take the common values outside in order to simplify this. So when we take the values outside, you'll take 2 outside, so 4a, you'll get, since 4 is common to both a squared and b squared, we're going to take 4 outside, so remaining on the inside would be a squared plus b squared. And we know that root 4 can be written as 2 root a squared plus b squared, which is equal to distance AB. In the second question, they've asked us to find the distance between the points 0, 0 and 36, 15. So we're going to take 0, 0 as point A and 36, 15 as point B. So the distance of AB will be, we're going to take this as x1, y1, x2, y2. So it will be 36 minus 0 whole squared plus 15 minus 0 whole squared. So AB is equal to root of 36 squared plus 15 squared. AB is equal to root of 36 squared is 1296, and 15 squared will be 225. So 1296 plus 225 will give us 1521. And the root of 1521 will equal 39. So the distance from this point to this point will be 39 units. In the third question, they're asking us to prove whether the points A, B, and C are collinear. The points A have the coordinates 1, 5, B, 2, 3, and C, negative 2, negative 11. So we're going to assume that these are points on the line. We need to prove that these are points on a line in order to prove that they're collinear. So if these points are collinear, then it can be represented in this way, where AB plus BC would be equal to AC if the points A, B, and C are collinear. So in order to prove whether this satisfies the coordinates that are given, we need to find the distance of AB, BC, and AC. So the distance AB would be, the coordinates of AB are 1, 5 and 2, 3, where we're going to assume this is x1, y1, x2, y2. Substituting this in the distance formula, we would get the distance of AB is equal to root of 2 minus 1 squared plus 3 minus 5 squared, which is equal to negative 1 squared plus negative 2 squared. 1 squared is 1, negative 2 squared is 4, so you'll get root 5. Next, we need to find the distance of BC. We know the coordinates of BC are negative 2, negative 11, and C, and then B's coordinates are 2, 3. So we're going to take this as x1, y1, x2, y2. So x2 minus x1. Substituting this in the distance formula, you would get x2 minus x1 squared plus y2 minus y1 squared. So negative 2 minus negative 2 will give us negative 4. Negative 4 squared is 16. And negative 11 minus 13 will give us negative 14. And negative 14 squared will give us positive 196. So when we add both of these values, we will get 212, and 212 can also be written as 2 root 53. Now finally we need to find the value of AC. So the coordinates of AC are 1, 5 and -2, -11. So the distance between these 2 points would be -2 minus 1 squared plus -11 minus 5 squared. -2 minus -1 will give us -3. -3 squared will give us 9. Plus -11 minus -15 will give us -16 squared, and -16 squared is 256. When we add both of these values, we'll get a root of 265. So now we know the values of AB, BC, and AC. Now, according to this, AB plus BC needs to be equal to AC in order to prove that these points are collinear. So the value of AB we have found out to be root 5, and BC is 2 root 53, which is not equal to root 265. Hence we can say that these 3 points are not collinear. In the fourth question, they're asking us to prove whether the given points are a point of an isosceles triangle. We know that in an isosceles triangle, the 2 sides of the triangle are going to be equal. So we're going to assume that the given 3 points to be a point on the triangle A, B, and C. We need to prove that AB is equal to AC, or AB is equal to BC, or AC is equal to BC. If any one of these satisfies, then we can say that this is an isosceles triangle. So first we're going to find, in order to prove that it's an isosceles triangle, we need to find the distance between each one of these points. So we need to find the distance of AB, we need to find the distance of BC, and we need to find the distance of AC. So first we're going to find the distance of AB. So we know that the coordinates of AB are 5, -2 and 6, 4. Substituting these values in the distance formula, we will get the distance of AB is equal to root of 6 minus 5 squared plus 4 minus 2 squared, which is 4 minus of minus 2 will give us 4 plus 2 squared. So you'll get 6 minus 5 is 1 squared, and 4 plus 2 is 6 squared. So 36, and 1 plus 36 will give us 37. So the distance of A and B is 37. Now we need to find the distance of BC. The coordinates of BC are 6, 4 and 7, minus 2. Substituting this in the distance formula, we would get 7 minus 6 squared plus -2 minus 4 squared. 7 minus 1 is 1 squared, and minus 2 minus 4 is minus 6 squared. Minus 6 squared is equal to plus 36. So 36 plus 1 will give us 37. And finally, we need to find the distance of AC. We know that the coordinates of AC are 5, minus 2 and 7, minus 2. Substituting the points on the coordinates in the distance formula, you will get the distance is equal to 7 minus 5 whole squared plus -2 minus 4 whole squared. 7 minus 5 will give us 2 squared, which is 4. -2 minus 2 will give us -4 squared, which is 16. So root 20. In order to prove that the triangle is an isosceles triangle, we need to prove that 2 sides are equal. We've already proved that AB is equal to BC, which is equal to root 37. Since both sides are equal, we can say that triangle ABC is an isosceles triangle? In the fifth question, they've given that in a classroom, 4 friends are seated in the points A, B, and C, as shown in figure 7.8. Champa and Shameli walk into the class, and after observing for a few minutes, Champa asks Shameli, "Don't you think ABCD is a square?" Shameli disagrees. Using the distance formula, we need to find which of them is correct. So, from the given points marked on the graph, we can deduce that the points A, B, and C are the given following coordinates. So A is equal to 3, 4, B is equal to 6, 7, C is equal to 9, 4, and D is equal to 6, 1. We need to prove whether these points form a square. We know that if a quadrilateral is a square, then all of its sides are equal and its diagonals are also equal. So in order to prove that, we need to find the distance of AB, BC, CD, AD, and its diagonals AC and BD. If all of these are equal, then we can say that this figure is a square. So first, we're going to find the distance between A and B. The coordinates of A and B are 3, 4, and 6, 7. Substituting this in the distance formula, we would get 6 minus 3 squared plus 7 minus 4 squared is equal to AB. 6 minus 3 would give us 3 squared. 7 minus 4 will give us 3 squared is equal to AB. So 3 squared plus 3 squared is basically 9 plus 9, which is equal to AB. So root 18 is equal to AB. Root 18 can be simplified as 3 root 2, which is equal to AB. Next, we need to find the distance of BC. So we know that the coordinates of BC are 6, 7 and 9, 4. Substituting this in the distance formula, we would get 9 minus 6 squared plus 4 minus 7 squared, which is equal to BC. 9 minus 6 squared will give us 3 squared. 4 minus 7 squared will give us negative 3 squared, which is equal to BC. 3 squared plus negative 3 squared is 9 plus 9, which is equal to BC. 9 plus 9 is root 18, which is equal to BC, and BC is equal to 3 root 2 when root 18 is simplified. Next, the distance of CD. We know that the coordinates of CD are 9, 4 and 6, 1. Substituting the values in the distance formula, we would get 6 minus 9 squared plus 1 minus 4 squared is equal to CD. 6 minus 9 squared is 3 squared, negative 3 squared, and 1 minus 4 squared is negative 3 squared. The negative 3 squared plus negative 3 squared is 9 plus 9, which is equal to CD, and root 18 is equal to CD. CD is equal to 3 root 2. Now we need to find the distance of AD. We know the coordinates of AD are 3, 4 and 6, 1. Using the distance formula, the distance AD will be equal to 6 minus 3 squared plus 1 minus 4 squared. AD is equal to 3 squared plus negative 3 squared. So AB is equal to 9 plus 9, and AD is equal to root 18, and AD can be simplified as 3 root 2. So now we have proved that all sides of the given coordinates which form a quadrilateral are equal, but in order to further prove that the given quadrilateral is a square, we need to prove that the diagonals are equal, so we need to find the distance of AC and BD. We know that the coordinates of AC are 3, 4 and 9, 4. So the distance of AC will be 9 minus 3 the whole squared plus 4 minus 4 the whole squared, which is equal to AC. 9 minus 3 will give us 6 squared, which is 36. 4 minus 4 is 0, is equal to AC. So root 36 is equal to 6. So AC is equal to 6. Now we need to find the distance of BD. The coordinates of BD are 6, 7 and 6, 1. So BD is equal to root 6 minus 6 squared plus 1 minus 7 squared. So BD is equal to root of 0. 1 minus 7 is negative 6. Negative 6 squared is 36. So BD is equal to root 36. So BD is equal to 6 units. Now we have proved that all sides of the given quadrilateral are equal and its diagonals are equal. So then we can say that it is a square. And since Champa said that ABCD is a square, we can say that Champa is correct. In the sixth question, they're asking us to name the type of quadrilateral formed, if any, by the following points and give reasons for your answer. So in the first question, they've given the points as -1, -2, which we're going to take as A, B, which is 1, 0, C is -1, 2, and D is -3, 0. So we need to find the distances between AB, BC, CD, AD, AC, and BD, which are the diagonals, and these are the sides. So if we using the conditions for quadrilaterals, we need to prove whether it is a quadrilateral, and we need to prove what type of quadrilateral it is. So first we're going to find the distance between AB. So the distance between AB would be 1 plus 1 whole squared plus 0 plus 2 the whole squared, which is equal to root 44 plus 4, which is equal to root 8, and root 8 can be simplified as 2 root 2. BC can be written as, the distance of BC is -1 minus 1 squared plus 2 minus 0 squared, which is equal to 4 plus 4, which is equal to root 8, which can be simplified as 2 root 2. CD, the distance of CD would be equal to -3 plus 1 squared plus 0 minus 2 squared, which is equal to 4 plus 4, which is equal to root 8, which is equal to 2 root 2. And AD, the distance of AD would be -3 plus 1 whole squared plus 0 plus 2 whole squared, which will give us root 4 plus 4, which is equal to root 8, which can be simplified as 2 root 2. Now we need to find the distance of the diagonals. The diagonals AC would be, the distance of the diagonal AC would be -1 plus 1 squared plus 2 squared, which is equal to root 0 plus 16. Root 16 is equal to 4, and now we need to find the distance of BD, which is another diagonal. So the distance of BD would be negative 3 minus 1 squared plus 0 minus 0 squared, which is equal to root 16 plus 0, which is equal to root 16, which is equal to 4. Since all of the sides of the quadrilateral are equal and all the two diagonals are also equal, we can say that ABCD is a square. In the second question, the given points are negative 3, 5, 3, 1, 0, 3, negative 1, negative 4, which we're going to name as A, B, C, D. So in order to prove whether this is a quadrilateral or not, we need to find the distance of AB, BC, CD, and AD. So the distance of AB would be 3 plus 3 squared plus 1 minus 5 squared, which is equal to root 36 plus 16, which is equal to root 52, which can be simplified as 2 root 13. Next, to find BC, the distance of BC would be 0 minus 3 squared plus 3 minus 1 squared, which is equal to root 9 plus 4, which is equal to root 13. And CD, the distance of CD would be negative 1 minus 0 squared plus negative 4 minus 3 squared, which is equal to 1 plus 49, which is equal to 5 root 2. Next, the distance of AD would be negative 3 plus 1 squared plus 5 plus 4 squared, which is equal to root 4 plus 81, which is equal to root 85. We will notice that none of the sides are equal. Since none of the sides are equal, we can say that these points A, B, C, D do not form a quadrilateral. In the third question, they've given the points as 4, 5, 7, 6, 4, 3, and 1, 2, which we're going to name as A, B, C, and D. We need to find the distance of AB, BC, CD, AC, and BD. So AB, the distance of AB would be 7 minus 4 squared plus 6 minus 5 squared, which is equal to root 9 plus 1, which is equal to root 10. BC would be 4 minus 7 squared plus 3 minus 6 squared, which is equal to root 9 plus 9, which is equal to root 18, and root 18 can be written as 3 root 2. CD, the distance of CD would be 1 minus 4 squared plus 2 minus 5 squared, which is equal to root 9. The distance of AD is equal to 1 minus 4 squared plus 2 minus 5 squared, which is equal to 9 plus 9, which is equal to 3 root 2. Now the distance of CD is root 1 minus 4 squared plus 2 minus 3 squared, which is equal to root 9 plus 1, which will equal root 10. Now we need to find the values, the distance of the diagonals AC and BD. The distance of AC would be 4 minus 4 squared plus 3 minus 5 squared, which will equal root 4, which is equal to 2, and the distance BD would be 1 minus 7 squared plus 2 minus 6 squared, which will be root 36 plus 16, which is equal to root 52, which can be simplified as 2 root 13. Here we will notice that AB is equal to CD and BC is equal to AD, and the diagonals AC are not equal. So AC is not equal to BD. Since the opposite sides of the quadrilateral are equal and its diagonals are not equal, we can say that the quadrilateral ABCD is a parallelogram. In the 7th question, they've asked us to find the points on the x-axis, which is equidistant from the points 2, -5 and -2, 9. So we're going to assume that the point lying on the x-axis to be x, 0. If a point lies on the x-axis, that means its y-coordinate will always be 0. We're going to name this point as O. And the 2 points, 2, -5, we'll name it as P, and the points -2, 9, we're going to name it as B. So if they're saying that we need to find a point on the x-axis, which is x, 0, which is equidistant from points P and B. If it is equidistant, that means the distance of PO will equal BO. So the distance of PO would be given as 2 minus x squared plus -5 minus 0 squared, which is equal to BO, distance of BO, which is given as -2 minus x squared plus 9 minus 0 squared. Now we will notice that the symbol of the root is on both sides of the equation, on the right hand side and the left hand side. It'll be much easier to calculate if we're able to cancel out both of these roots. So in order to do that, we simply square on both sides. So when we square on both sides, this and this will get cancelled. So we will be left with 2 minus x squared plus -5 squared, which is equal to -2 minus x whole squared can also be written as 2 plus x squared. When we multiply minus with both, we will get +2 plus x, so -2 minus x squared can also be written as 2 plus x the whole squared, plus 9 squared. So this is in the form a minus b the whole squared, so it can be written as 4 minus 4x plus x squared plus -5 squared is 25, which is equal to, this is in the form a plus b the whole squared, so it can be written as 4 plus 4x plus x squared, and 9 squared is 81. X squared and x squared will get cancelled. 4 and 4 will get cancelled. So we're going to bring the values on the right hand side to the left hand side. So you will get -4x minus 4x plus 25 minus 81, which is equal to 0. So -4x minus 4x will give us -8x, and 25 minus 81 will give us -56, which is equal to 0. Bringing -56 over to the right hand side again, we'll get minus 8x is equal to +56. So x will be equal to -7. So the coordinates required, which is equidistant from the point P and B, would be -7, 0. In the 8th question, they're asking us to find the values of y for which the distance between the points P 2 comma negative 3 and q 10 comma y is 10 units. So they've given the distance between the points P and Q to be 10, and we need to find the unknown values of y. So in order to do that, we're going to use the distance formula, and we're going to find the value of y. We know that the distance of PQ can be written as 10 minus 2 squared plus y plus 3 squared. And we already know that the value of PQ, the distance of PQ, is 10. So we can substitute that value in here, which will give us 10 minus 2, which is 8 squared, plus y plus 3 squared. And now we'll notice that there is the root on the right-hand side of the equation, but there is no root on the left-hand side. It'll be much easier to calculate if we're able to remove this root symbol. So in order to do that, we're going to square both of the sides of the equation. When we square both sides of the equation, we will get 10 squared, which is 100, and the square and the root will get cancelled, so we will get 8 squared plus y plus 3 squared. Y plus 3 squared is in the form a plus b the whole squared, so it can be written as y squared plus 6y plus 9, and 100 is equal to 8 squared. 8 squared is 64 plus y squared plus 6y plus 9. Since the highest power in this equation is 2, we can say that this is a quadratic equation, and we'll get two solutions for the values of y. So we're going to rewrite this so that it is in the form ax squared plus bx plus c. So we're going to bring the values to the right-hand side, to the left-hand side. So you'll get 100 minus 64 minus 9 minus y squared plus 6y is equal to 0. And 100 minus 64 minus 9 would be 27 minus y squared plus 6y, which is equal to 0. And we're going to rewrite this so that it's y squared plus 6y plus 27, which is equal to 0. And we're going to multiply this whole equation with minus so that it'll be simpler for us to calculate. So we'll get y squared minus 6y minus 27, which is equal to 0. So now we need to solve this quadratic equation. So in order to solve this quadratic equation, we need to find two numbers in which its sum is negative 6 and its product is negative 27. So the two numbers which I can think of would be negative 9 times negative 9 and 3. When you multiply negative 9 and 3, you'll get negative 27. And when you add negative 9 plus 3, you will get minus 6. So we're going to substitute these two numbers in the quadratic equation, which will give us y squared minus 9y plus 3y minus 27, which is equal to 0. Taking out the common terms outside, you'll get y minus 9 plus 3y minus 9, which is equal to 0. Since both the values and terms inside the bracket are equal, we can say that this is correct. The two factors of this equation would be y plus 3 is equal to 0 and y minus 9 is equal to 0. So y will be equal to negative 3, or y can be equal to positive 9. So both of these values of y will satisfy the given question. In the ninth question, they've said that if q 0, 1 is equidistant from the points p, 5, negative 3, and r, x, 6, we need to find the values of x, and we also need to find the distance of qr and pr. So they've said that the point q is equidistant from points p and r. So since it's equidistant, we can say that distance PQ is equal to distance QR. Using this, we're going to find the value of x, and after we find the value of x, we are going to find the distance of QR and PR. So since PQ is equal to QR, the distance PQ is equal to QR, we need to find the distance of PQ, and the distance of PQ is given by 5 minus 0 squared plus 1 plus negative 3 minus 1 squared. It is equal to QR. The distance of QR would be x minus 0 squared plus 6 minus 1 squared. In order to remove the root symbol, we're going to square this on both sides. When we square on both sides, both of these will get cancelled. The square and the root symbol will get cancelled. So we're going to be left with 5 minus 0 squared, which is 25, plus negative 3 minus 1, which will give us negative 4. Negative 4 squared is positive 16, which is equal to x squared. 6 minus 1 is 25, so positive 20. 6 minus 1 is 5, and 5 squared is positive 25. And 25 and 25 will get cancelled, so you will be left with x squared is equal to 16. And when you bring the square over to this side, it becomes a root. So root 16 is equal to 4, so the value of x is equal to 4. Now we need to find the distance of... The value of x can be positive plus or minus 16. So the value of x can be either positive 4 or negative 4. So now we need to find the distance of QR and PR, in which the values of x can be either positive 4 or negative 4. So the distance of QR would be x minus 0 squared plus 6 minus 1 the whole squared. So we're going to take x, the value of x as positive 4. So when we take the value of x as positive 4, we would get 4 minus 0 squared plus 6 minus 1 squared, which will give us 16 plus 25, which will give us root 41. And the value of PR when x value is positive 4 would be 4 minus 5 whole squared plus 6 plus 3 the whole squared, which would give us negative 1 squared plus 9 squared, which is 81. So the distance of PR would be root 82. So if we're taking the value of x as a negative 4, then the distance of QR would be same as the distance of QR would be negative 4 minus 0 squared plus 6 minus 1 the whole squared, which will give us root 41. And the distance of PR, if the value of x is negative 4, would be negative 4 plus minus 5 squared plus 6 plus 3 squared, which will give us root negative 9 squared plus 9 squared, which is root 162, which can also be written as root 9 root 2. So this is the values of QR and PR when x is equal to negative 4, and these are the values of QR and PR when x is equal to 4. In the 10th question, they're asking us to find a relationship between x and y such that the point x, y is equidistant from the point 3, 6 and negative 3, 4. So we're going to take the point xy as 0 and the point p as 3, 6 and the point q as negative 3, 4. So we need to find a relationship between x and y such that the point xy is equidistant from points p and q. Since they're saying that it's equidistant, then it is safe to say that the distance OP is equal to OQ. So the distance of OP would be given by x minus 3 squared plus y minus 6 squared is equal to x plus 3 squared plus y minus 4 squared. In order to cancel out the roots, we're going to square on both sides. And when we square on both sides, the square and the root will get cancelled. So we'll be left with x minus 3 squared plus y minus 6 squared, which is equal to x plus 3 squared plus y minus 4 squared. So x minus 3 squared can be written as x squared minus 6x plus 9, and y minus 6 squared can be written as y squared minus 12y plus 36, and 3 plus x plus 3 squared can be written as x squared plus 6x plus 9, and y minus 4 squared can be written as y squared minus 8y plus 16. Now x squared and x squared will get cancelled, y squared and y squared will get cancelled, and 9 and 9 will get cancelled. We're going to bring over the remaining terms over to this side, so you'll get 6x minus 6x minus 12y plus 8y plus 45 minus 25, which is equal to 0. So minus 6x minus 6x will give us minus 12x minus 4y plus 20, which is equal to 0. Since all of these terms are multiples of 4, we can cancel them by dividing it by 4. So you will get negative 3x minus y plus 5, which is equal to 0. And in order to simplify this further, we're going to multiply this by minus. So when we do that, you will get 3x plus y minus 5, which is equal to 0. And this would be the relationship of x and y.